Hello everyone, and then welcome to another video. So in this video we'll be treating partial derivatives. Okay, so we've already talked about limits and then how to find limits and all that. So we'll be talking about partial derivatives. Okay, so let me just break this in their simplest form. Okay, so partial derivatives is all about let's put it in this way. It's just like chain rule. Okay, so in case you know chain rule, you decide to differentiate one variable and then leave the other variable. Okay, and then sometimes you decide to do vice versa. Okay, so that's what partial derivatives stand for. Okay, we tend to differentiate one variable, okay, and then leave the other. Okay, so it means that once you are not differentiating that variable will be omitted. Okay, so that's what partial derivatives is all about, so that it will get to sound a bit simpler than what I'm about to explain. Okay, so in case you are new to this channel, I would urge you to subscribe to the channel, turn on your post notifications so that you don't miss out on any uploaded video. Like the video, share, then let's proceed with this video. Okay, in case you have any questions regarding this video, I would urge you to leave them in the comment section and then I'll reply to them as soon as possible. Okay, right, so let's say we consider what a function, let's say z, to be what f of what x and y. So a function will be x and y components. Okay, so we have x and y components, so consider z to be equal to f of what x, y in a domain that contains x naught and y naught. So what this means is that we have a function z, okay, with x and y components, and then it will be substituted with what x naught and y naught. So x naught and y naught are like values, okay, numbers which we usually substitute into the main expression to get a specific answer. Okay, now the partial derivative of f with respect to x, that's x naught and y naught, could be represented in this form. Okay, so in case you initially understood the initial explanation I gave, okay, there's no need to bother yourself with this. Okay, but you need to know the formula. Okay, you need to know how you represent them. So this is because in our next lecture I'll be treating what partial derivative with respect to what tables. Okay, so once you understand these formulas, that subtopic will be what much easier for you to understand. Okay, so now let's proceed. So for the function, differentiating the function with respect to x, this is how you represent that, and then after this, how you represent this form. Okay, in this format, okay, like this. But once you try substituting with respect to what x naught and z naught, you then write them in this form. Okay, that's in the form of a limit format, not as if it's in a limit form, but you are just substituting the values or numbers into the original equation. Okay, that means you'll be given value for x, value for y, and then you do what, substitute. Now this is respect to what, x. Okay, now let's see, once we are differentiating with respect to y. Okay, that's why initially I stated that you'll be differentiating with respect to x, and then sometimes you'll be differentiating with respect to y. Okay, now so let's see. So once you are differentiating with respect to y, this is how the formula will look like. Okay, and then once you substitute with what, x naught and y naught, this is how you substitute, or this is how your formula will look like. Now, without further much ado, and then trying to cut the long talk short, let's try solve some questions so that you get to understand the entire concept. Okay, right, so let's take these examples. Okay, so let's see how we find what the respective answers. Okay, right, so you are given what, you are told to consider this function. Okay, the function which is what, z, which is equal to what, 3x squared, okay, y cube minus what, 4x, okay, plus 9y plus what, 93. Okay, so we have to differentiate with respect to x. Okay, so that's why we have of f of x. Okay, so this is what we are to solve. Okay, we are differentiating with respect to what, we are taking the partial derivative of this function, okay, of this expression with respect to only x. Okay, and then we are not given any values for what, x and y. Okay, so all we have to do is just differentiate. Okay, take the partial derivative. Okay, one thing you need to know is that once the function you are told, or the variable you are told to differentiate has, let's say you are told to differentiate with respect to x, and then you have y attached to the x. okay, once you have y attached to the x, you will not omit the what y, okay. But once you don't have any x attached to the y, just as in this form, you would have to omit the what, the y component, because you are just differentiating respect to x, not respect to y, okay. So let's solve this and you get to know how this is done. So we are differentiating respect to what, x, okay. So whenever you see x, we just differentiate, okay, we take the derivative. So when you differentiate this, you end up with what, 6x, okay, y cube, okay, and then we have what, minus what, 4, okay. Now from here you could notice that you don't have any x attached to this expression, so this goes to what, 0, okay. There's no need to write that, but I want you to see how this is done so that you get to understand, because for subsequent differentiations or partial derivatives, I won't be going through this again, okay. I just want you to grab the concept and then we move from there. So now this also doesn't have any x attached to it, and since we are differentiating in respect to x, okay, taking the partial derivative with respect to x, this also goes to 0, okay. So we have what, 6xy cube minus what, 4. So this is our final answer, okay. See how simple this is, okay. Now let's take the second one, okay. We are taking what, I, okay, which is what, we are taking the partial derivative, okay, with respect to x, okay, and then we have x, and then what, we are given only the y variable, okay, we are given only the y variable. So this means that we are given this in this format, okay, taking the derivative, but we are given only this, okay, we are given only this, not the x component. Now let's take the what, the derivative, okay, the partial derivative. So we have what, from the same what, expression, okay, from the same expression, okay. So we have what, when you differentiate this, you end up with what, 6x, okay, y cube, okay, and then we have what, minus 4, okay, and then this goes to 0, just like here. Now all you have to do is just substitute what, the y component, okay, because we are given only y, not x, okay. Again, you could notice that we are giving x to what, x, okay. So you could just go by this. So you have 6x, and then you insert your what, y component, which is what, 3, okay, exponent 3, okay. Then we have what, minus 4. So when you compute the whole of this, 162, okay, 162x minus 4, okay. So these two are not like terms, so you cannot add them. So we end the what, solution over here, okay. So let's take the next one. We have what, f of x 1 and 3, okay. So we have what, I, which is what, we are differentiating with respect to x, and then we have x value, then y value, okay. So let's take the derivative. So now you've been given this in this form, okay. Note that you are given this in this form, okay. So now let's take the partial derivative, okay. So we have what, let me rewrite that, let me rewrite the equation, okay. So we have 3x, it's 3x squared, okay, y cube minus what, 4x, okay. Then we have what, plus 9y, okay, and then plus what, we have what, 93, right. Now let's take the what, the partial derivative with respect to x, okay. So we have what, so this is something like this, okay, something like this. So I didn't introduce that initially, but it's the same thing, okay, right. So we have what, 6, okay, x y cube, okay, minus 4, okay. So from here, this is how you end the what, the partial derivative. Now let's substitute, okay. So we have what, 6, then we have 1 over here, okay, 1, and then we have what, y, which is what, 3 exponent 3, okay, and then minus 4, okay. So we are just substituting our values, okay, these values into the main equation, okay. And then when you compute this, you end up at what, 158, okay. So 6 by 1, then you multiply that by 3 exponent 3, and then subtract that from what, 4, you end up at what, 158, okay. So let's take the last question. So we have what, f of y, okay. So let's take the what, now you are trying to differentiate with respect to what, only y, okay. We are taking the partial derivative of y, means that we are trying to differentiate only y and then leave x, differentiate y and then leave x. So we have what, 3 x squared y what cube minus 4, okay, plus 9y plus 9 3, okay. So we have what we are differentiating with respect to what only y, okay, only y. So we have what this will give us what 3, and then we have what 3x squared, and then we have what y squared, okay. So this will be what, yes, 0, okay, and then we have what plus 9, and then this will be what 0, okay. So when you proceed from there, we have what we try to substitute with what our values, okay. So this is what f of y, okay, and then we have x naught and then y naught, okay. So we have what 3, and then we have 3, then we have what x value, which is 1 squared, okay, and then we have what y, which is what 3, okay. So we have 3 squared, and then we have what plus 9, okay. When you compute the whole of that, so we have 3, okay, open bracket, 3 times 1 all squared, and then this is what close bracket, and then we have what 3 squared plus what 9. When you compute all of this, you end up with what 90, okay. So this be our final answer, okay. So we've talked about what differentiating with respect to only one variable, okay, that's partial derivative, okay. But from here you could notice that we have only two variables, okay, xy in all the examples. So what if you come across three variables, okay? How do you differentiate with respect to, or you partially differentiate with respect to what three variables, okay? So let's look at how we solve that, okay. Now, so we have partial derivatives for more than what two variables, okay. So consider a function w with respect to f, and then we have x, y, z, okay, and then we are given an example, okay. So let's try solve what let's take the partial derivative for each of these questions, okay. Let's say y, okay, the first one, okay, or I, okay. So we are taking the partial derivative of the function, this function, okay, this entire function, but with respect to only x, okay. So let's try that. As we've already done that, so you just use the same approach, okay. So we have what 6x y from here, then this will go to what 0 because it doesn't have any x variable, okay. Then we come to this portion, so we have what minus what 4z, okay, from here, and then this goes to 0, okay. Now let's take the second one. We are differentiating, okay, partially differentiating with respect to y. So we have what 3x squared, okay, because we have y over here, and we don't have any y over here, but we have y over here. So this goes to 0, this goes to 0. So we have what plus 4y, okay, yes, because we have y over here, okay, we have y over here. So let's take the last one, which is partially differentiating with respect to what z, okay. So this is the main question. So let's do the partial derivative, okay. So we have what this goes to 0 because we don't have any z over here, and then we differentiate with respect to what this portion. So we have what 9z squared, okay, and then we have what minus 4x. So this goes to 0, okay. So because 3 by 3 is what 9, okay, yes. So this is how you differentiate with respect to what you partially differentiate with respect to two variables, and then what more than two variables, okay. I hope this video was very helpful. In case this video was very helpful to you, I would urge you to subscribe, hit on the bell icon, and then I will see you in the next video. Don't forget to leave your questions in the comment section. Bye bye.